Okay. Yes. Hi again. And we continue our journey into knowledge representation or management and reasoning. So we are, yeah, where are we, so to say, on the course timeline? So what did we talk about yesterday? You have only two courses. I mean, you should remember. I have more things to remember. So, yesterday, what did we talk about? Okay, maybe a hint. Apples. Apples. Ah, that was the day before yesterday, if I remember correctly. Yeah. So we had a class yesterday. So on Monday, yes, we talked about fuzzy logic. So ripe, unripe, chutney, cider, calvados. Yeah, I like more calvados, of course. But
Yesterday was John loves Mary or something.
yeah, John loves Mary. Yes, exactly. Yeah, this thing. We will come to it now. You remember? Yeah, good. But I mean, so what it is all about? What has John have to do with this subject and the fact that he loves Mary? Relations, yes. So in the first week, first theory module, we talked about logical agents, like a general formulation of need of reasoning. So we need to at the end, we want to create programs that has a kind of a universal engine to process facts and relations about these facts in which these facts appear uh, in a standard way. So in this way, so we create a more flexible software. So we don't need to hard code it. We don't need to update the execution logic itself. So all logic will be uh, in the implemented inside the logic. Sorry for the tautology. So we will represent. First of all, we will make an abstraction from physical world objects and move it into a logical world, into logical world representations, on which we apply certain um, um, logic formalisms to derive conclusions, to derive new facts from based on existing facts. And so we started in the first module, so to say, with classical logics. And yesterday, so I talked about well, a general framework of reasoning. So we have two alternatives here, so with respect to completeness of the knowledge base. So knowledge base is a storage where we will collect the facts and the relations between stuff. And on top of it, so we will implement certain, as I said, a program implementing logical inference based on these facts. And two variants of reasoning or inference uh, stem from whether we have complete set of facts in our knowledge base, in our storage. In this case, we say that we have a closed world model. So we know our domain, so we described it, we introduced our assumption about certain the domain again. So we introduced the rules to be checked for not contradicting, and within this database, given some input facts, that we get from our sensory system, we do inference, and inference is done based on checking all applicable rules. And then if something goes wrong, so that some rules are found to be contradictory, so we need to do extra actions. So our logic engine should support revision of these facts and relations. And this is versus so-called open world model, where you cannot describe a complete set of rules about the domain. And this is applicable to a large variety of real systems, large-scale systems. And the only assumptions you may have is that if you don't know something about an object, probably you simply haven't discovered it yet. So you so all previous inferences that you do, they do not invalidate. They are not invalidated by adding new facts. Right, and and classical logic belongs to the second variant. So that's kind of taxonomy of reasoning. So what we want to have, but then I moved on into something kind of more complex than encoding real-world objects as Boolean variables. So if you remember in propositional logic, so we assign symbols to physical entities. So we name them somehow, identify. So identify is a good keyword. And say, okay, so the range of values for the symbol either true or false. And then it kind of allows us to develop a theory, how to do reasoning, so how to do inference, simplify logical formulas, etc. But what about real world? Well, I touched a little bit on this kind of complexity when introducing the fuzzy logic, as you mentioned, so that not everything is binary in our world, and so sometimes you want to reason. Taking into account some imprecise definitions of objects. So that was one case. But then you can move on and just generalize it to our real world and say that, well, it's not only about imprecisely defined values. Sometimes you can define precise values. Sometimes certain objects can take values in a certain range, and then so objects can interact with each other in different ways, so be included in different relations. They can be they can have a compositional structure. Well, not can, they do have. So as I said previously, so do this mental exercise. Take any skill or any object, a box of chalks, and try to describe it like to the tiny detail. So you will obtain a rather complex description of if you break it down to even to chemical elements. And then you will notice that, of course, some parts are shared between different entities. So you will see emergence of classes, etc., etc. So we need a formalism, or not a formalism. We need a more expressive way to encode knowledge, so that we, on top of it, we can implement reasoning. And I introduced that's one of the probably most global attempts. So that was a most global attempt baked by baked up by interest from industry, different industries, and it was driven at that time, driven by really a hype of the internet. So I'm talking about back in end of 90s, beginning of 2000. So internet was a probably as big thing as ChatGPT today. Maybe bigger, of course. Um, so and altogether, so that was that sparked this development of a vision that information that we otherwise link as documents, as textual documents, is just, I mean, it can be more just data. So you can add meaning to it. So I add semantics to it. So because again, it's simple. The idea is simple that behind any text there are some physical objects located. Like if it's a personal web page, it's a person, and so referring to a specific place of employment. So this person is engaged in an employed by relation with this with the employer. So how to make this transition? So from data or from data to meaning, and and link it in a similar way as documents used to be linked. And moreover, I remember that, I mean, this vision can be further propagated not only on the information which inside documents, but to the documents themselves, because they become they are objects and on their own, and they are engaged in relations between each other, and etc., etc. So a web page can have a date of birth or date of creation, and they, I mean, by the fact that it's referring to something that, or it has a hyperlink to some other page, so it refers to something, etc., etc. So in principle, you can reason about any objects in the world in a unified way if you have standardized way of representing information. And that's what we ended with. So yeah, John, Love and Mary. So remember that our last discussion was that we want to represent this world's complexity. So we want to create a knowledge graph, basically, maybe for a particular domain, but maybe for the whole universe. I don't know. And what is needed for that? Well, to begin with, we need identifiers. So we want to disambiguate the objects and the subjects and relations. And so identifiers, as I mentioned, and I will return back to it soon. They are universal resource identifiers, again, being standardized on the World Wide Web group. And importantly, that it's not the objects that needs to be identified, but like everything. So even the naming of relations should be identified, because same so there could be different physical relations hidden behind the same name. So, and you need to disambiguate it. So when you do that, so when your computer can kind of uniquely name the stuff, then you can start building your knowledge base. And I also introduced that one of the building blocks, fundamental building blocks, is something which is called resource description framework. It is a standard, and it provides. It was created with an idea to provide interoperability between digital entities that exchange information. It's important, and I will come back to it. So what you do with RDF, you describe a data model. So we are not there yet with reasoning and such. So RDF is created just to describe data. And some primitive relations. So key concepts in RDF. First of all, the fundamental construct in RDF is a triple. It's an atomic unit. So statements, all statements will be described by triple. And of something. Resources in these statements will be identified by universal resource uniform resource identifier. And then, as I said, so you describe your domain with in this way with triples, and so the way how you describe it will result in emergence of a graph. So how different concepts relate to each other. And now you will see its actual graphical form soon. So RDF triple, important. I mean, that you should probably remember. Subject, predicate, object. So something relates to something. Something is something. Subject is the resource being described. Predicate, relation, or a property. So an object is a value of this property. Let me see if I have it in the correct order. I think okay, I will jump back and forth. For example, so this is a little bit so I will come to the format, details of the format of RDF soon. So there could be different notations, but this is one of the examples of RDF triples. So we have Alice, some identifier, and which is who is a person. And so here you can, I mean, this tabulated part presumes that you have Alice in all places. So she has a name, etc., etc. So important thing is that is to think about identifiers. So where they come from? I mean, how to name things. What you can do, you basically have two options. The most kind of straightforward option is to invent your own names or your own namespace. So you as a designer of knowledge or a knowledge engineer, so the research jobs, or they used to be such jobs. You can decide on how you name different objects. So starting with this, I mean, like a person written in this way, maybe with some underscore or anything else. Or you can rely on kind of conventions. So people for interoperability purposes agreed on certain conventions, or agreed and agreed. Some conventions become de facto common. So a group of people, met at a workshop and say, okay, how we shall describe people and or human beings and their relations. And they say, okay, again, so that's an obvious thing. So a person has a name, it has a mailbox, it has a home page, he has a home page or she, and then this is a set of relations a person can be engaged into. And then they create a description. Um, and then they make this description publicly available. And so that many people, instead of inventing their own notations for objects, may use these identifiers. So one of this collection of names describing people and relations are called friend of a friend. So it's one of the earliest but widely known vocabularies. So whenever I mean, you can see this FOAF acronym in different places. How does it look? Well, in principle, whenever you publish it, so it should be accessible. So this link, however, is not accessible. So the website is down. But this brings us to an interesting discussion. For starters, so just to show you that this name space exists. So I found a copy of it. So let's open it with text editor. So this is a something. This is a document, an XML, or not in XML, in RDF format. So in RDF, everything is in RDF. So it's a kind of language that uses itself for everything, which actually describes a person. And a collection of these statements, we will talk about it more in detail next time, is called an ontology. So like a complete description of a domain using as a graph, showing the hierarchy of entities and different properties is called an ontology. So friend of a friend is an ontology describing a person. And so you can call it, you can see that, for example, it starts with the definition that person is a class. And again, so when thinking about, say, RDF and ontologies, you should maybe even connect your experiences from object-oriented programming. So there, I mean, it's pretty close intuition here. So here, the only thing is different that you don't. It's not actionable description. So it's just a declarative description of who or what objects are and how they relate to each other. Yeah, so basically you can scan it and see different details. Let me just go back to this person. Control F. And if I can find it. Well, because you define the terms themselves and then you use them as properties. Yeah. However, as I said, so this vocabulary is not accessible by the link given. What does it mean? Well, it doesn't actually mean that something is broken with respect to usage of this naming. So it's so this collective description or collection of descriptions which people agreed upon, it is served as a reference. So in the context of RDF, the subject predicate object stuff. So this is merely an identifier. So this document, in this case, describing an instance of a class person, Alice, is a self-consistent thing. So the fact that you use this identifier, but it is not retrievable, doesn't change anything. So it will be interpreted as is. So the only thing it can tell you that you use certain conventions for identifying subjects or objects. And if needed, you can go on and query this vocabulary. So only at the step of querying, of course, the vocabulary should be available somewhere, hopefully at this address. But the description using it doesn't rely on vocabularies being online. So another collection of descriptions. So let me see if I, no, yes, it's still sharing. That you also see in different contexts is something which is called Dublin core. So Dublin core is again is a naming space for describe. Let me see. Describing digital resources, documents, images, etc. This one is online, so you can go and, for example, oops. So I'll show you. So this vocabulary is online. So let's see if it happens. Yeah. So you can go to this website and basically see how these different objects are defined. But again, so this is a convention, so that you don't invent, first of all, you don't spend time on inventing your own terms on how to describe knowledge. But as I said, knowing that such collections exist, you can go on and use it for describing, creating your own descriptions of the domain. For example, you just want to describe domain of movies with a specific story behind it. So go on and use this namings, title, creator, etc., etc. Yes. So let me see where we have been. So, but all in all, independently what your focus domain is, so everything is described as triples. So once again, so here it's a paper type of text. It has title, paper has creator, mills, etc., etc., etc. Let's talk about subjects. Again, so maybe I'm talking about very primitive concepts, but I think it's there are some important moments just to keep in mind. So again, subjects inside triples, they can be identifiers. So we talked about identifiers before, or they also could be something which is called blank nodes. So let me just remove this stuff. Yeah. So what is a blank node? A blank node, it's a placeholder for a resource that exists, but by some reason you don't. There is no global identifier to it. So and here how you go about it. So there should be a description, and it will be inside your RDF document, but you just don't give an identifier to it. So this is something as you create, and the system takes care of assigning a random identifier. So you interpret it as that Alice has address something. So, and then it's a compound concept, which and this something has street, city, and country fields. So predicates, the predicates are always identifiers. And again, so they follow common vocabularies. So you normally don't invent them. Or if you invent them, so then this vocabulary should be queryable and publicly and available. So if you want to make your knowledge description usable. As for objects, so I already named it, mentioned it last time. Objects can be identifiers or literals. So when we talk about identifiers, then it means that you refer to some other object, while literals are concrete values that a subject can take. So, and this is a formal definition. So you can also tag it with, for example, do a language-specific tag. So let's do something again primitive, but maybe useful. So we want to characterize or we want to describe a web page. So we have a personal web page with this URL. Well, I think it's well, obviously it's a fake, and we want to describe it's that this Per Johansson is a creator of this page. So that will be our graph. So that we want to have at the end. So how we can go about? So there are different ways you can meet around which kind of present RDF statements. So so one of the standard ways is an XML format. So I mean, normally an RDF document you see it as an XML like this. And in this document, so when you see this description, then you can, again, identify a subject, a predicate, all this tag, and an object. And then, importantly, we already met it in the previous examples. If you use or if you want to refer that some identifiers are taken from publicly available places, then you indicate it in a prefix, so for brevity. So, and it means that this statement itself should be augmented with a header where you describe the namespaces, so the addresses to the namespaces, where to take them. And that's what I said that, I mean, so talking about discussion, the difference between object being a value or another object. So in one case, here we have a concrete value, a string of characters, and in the second example, so we have an identifier that leads to the description of the identifier of this object. So it's an object itself. So RDF documents are of this kind. So we will see now another notation for it. But as I said, series of statements, they construct a knowledge graph. So, and you can visually represent this knowledge graph. So where subjects and objects will be nodes and edges are predicates. And the convention is that ellipses are used for resources and rectangles for literals, like this one. And altogether, but we will talk interchangeably. When you say RDF graph or knowledge graph, in the first place is just a set of RDF statements. And then you can query this. So you should see it as a database at the end, which stores these triples. And as with any database, you can query it. So you can send queries in a special language, which is called Sparkle. We will be talking about it in a couple of classes from now. So let's maybe take a short break before we continue. Okay, so now it will be some action, I hope. Yeah, so we take this thing. So now what I want to do, I want to show you a couple of useful tools. So one useful tool is something which is called RDF validator. So you will use it in one of the quizzes for sure. So if you go to RDF validator, so you see a page like this. So as I mentioned, so the semantic web technologies are left after the this visionary global project, plenty of useful tools and standards. So this is one of the tools which allow you to validate your RDF statements. So you can go to so what is it again? www.3.org RDF/validator, and you can actually paste your RDF document inside. So here. And what you can do here, so you can ask to parse it and produce different types of outputs. So one of the outputs of interest is that we will use today is to extract the triples and to show a graph. So now if you do that, so then this is the result of this document being parsed. So it identified a single triple and build a graph, so very advanced graph, which shows that this homepage has a creator and identifier of the one who created the web page. Yes. Well, you can also meet RDF in other different syntactic flavors. So there is a so-called RDF XML abbreviated form. So where you emit this bulky XML statements or keywords and just specify the triples in a more kind of in a cleaner way. So all in all, if you want to describe a triple, so here is the classical format, so XML format. But then there was another invention. And again, I will show you towards the end that the idea with this notation was larger than merely producing a compact description of RDF document. But this is something which is widely used, and that is what you seen previously when I demonstrated, for example, friend of friends, a usage of the friends of friends vocabulary. So let's dive deeper into this N3 syntax. So N3 stands for notation tree. It was developed by Tim Berners-Lee, so one of the web inventors, and it was designed well primarily for better readability of this of the knowledge bases. So here is the idea. So you basically the idea is to compactly describe a set of triples. So if you have triples which share subject and predicate, for example, so you can compactly write them as a comma, and you can write them as many as possible. They importantly, so you every n3 row should be terminated by a dot. So there is another notation, which is a semicolon notation, and that's what you will exercise now. So this is when only a single, well, a subject is being same, and so predicate and objects are different. So very often you see this description, which I said, so now you can map it to this case. So we have subject and different predicate objects, which can be unrolled to this set of triples. So and tree notations can be quite sophisticated. So it's basically in one sentence you can encode rather many triples. You also can describe your sentence with this empty nodes. So when you don't want to give a name to a concept. And now you will try to decode it yourself. So once again, so you can see such a large string in entry notation. So at the end, it will be unrolled to quite many triples, actual triples. So now, parse it for me. I mean, you can just tell it to me, say verbally. So what is it being represented here? Because this is the language actually people use to create knowledge bases. So I'm not. I mean, so if you ever be involved with creation of knowledge base, most likely you will use this language. So that's why I'm kind of stopping at this point and waiting for your verdict.
Book has author but don't have a like reference to the author where you have its information in a bracket.
Yes. So the parser will actually exactly. So that's totally correct. So it will create unroll is something like this. So a book has an author, And the author has a name and a contact, and the contact has email and a phone. Okay. So then again, so you can actually go ahead and describe, create a story about yourself. So describe your own, describe yourself as a set of RDF statements. So this is a story about myself. And I just want to give you a couple of, again, modifications of it. So what does it say? So it has 4 facts. So about my gender, my mother, and my two hobbies of mine. So what do you see here? Oh, sorry. So same information is presented as triples. So here, well, again, each row is, well, first row is the subject, predicate, object. Subject, predicate, object, subject, predicate, object. Right. So that's what we want to describe as RDF. So, and that would be the actual document. So the actual document represented this knowledge. So what you can do again, so you can go and and. So let's see if it will parse it for me. Most likely not. No. So something is wrong. So that's not the correct website for doing that. So the website that I showed you is for visualizing RDF statements in XML format. So what you can do, so there are other tools. So if, for example, this site doesn't help you, so what you can do now, you can use one of the converters. And again, I'm showing this to you because you might expect this question, this kind of manipulations for one of upcoming quizzes. And now if we, oops, back. If we take this N3 statements and place it here. So let's see if it will eat it up. Yes. So I wanted an RDF XML. So this website doesn't do any visualization, but it converts it to a proper RDF format, which you can take now to the visualizer. And now, hopefully, yes. and now it actually digested it quite correctly. So what do you see here? So this is a knowledge graph of myself, and now I want to extend it a little bit, so I make it a little bit more complex. I want to add a statement that I have. So one of my hobby is a hobby of my mother, for example. But I don't again. So I don't want to give it a name. So that's the meaning with the empty uh, the idea with the empty node. So that's what I do. So I augment this description that I also have a hobby that is a hobby of my mother. And that's what I do here. So and this is my definition. So which presumably is located. Oops, sorry. Is presumably located at this address, but again, so this is just an identifier. So I invented my dictionary for naming the predicates, and I say that the last hobby is the hobby of so something which is a hobby of my mother. So how do I express it in triples? Well, I express it like this again. So let's try it because I didn't visualize this one with the empty nodes. Let's see. So we first need to convert it. So now we have our converter. So let's see if it submit. Yes. Now we take it and visualize it here. So let's see what it shows us. Yes, so plenty of triples, and here is the resulting knowledge graph. So what is going on here? So you see this arc, the edge. So that this is, well, you don't see. So this is a has mother predicate. And this is how an empty node is visualized. So a system creates a node for the concept that is not defined otherwise, and link it to with a specific predicate to my mother. So here is a notation for the empty node. So far, so good. And using these techniques, you can start describing quite sophisticated, well, you can create a sophisticated model of your data. So let me see. Yeah, so there are different visualizers you can find in the internet. So this is another one, so you can try. So at home, so not now, but I mean, you can try using these examples to describe your stories and try to parse it using the tools I showed you. Then another concept which is worth remembering in this context. So when you want to treat statements as data, I will show you an example. you can do that. And this process allows RDF to describe statements as data is called reification. Sorry, reification. Yes, of course. And with this, you can kind of describe, certain statements and beliefs, for example. So, for example, you can encode one statement, for example, Bob likes chocolate, as a resource. And then you can use it to describe, for example, in a statement that somebody believes that Bob likes chocolate, referencing it as a resource. And the process of converting a statement to a resource is called reification. So we are kind of moving towards the end. What is RDF? RDF is a language to describe your data. To present a primitive knowledge, to represent a primitive knowledge. So basically, what you can do with RDF is to describe facts, factual data. And if needed, again, for certain purposes, you can describe statements that that somebody has statements about something. What RDF is not, it is not in itself a knowledge, and it doesn't allow logical inferences. So it cannot. You cannot represent statements like if-then statements, for example. You cannot represent rules in RDF. So in essence, RDF, as I said, is just a model of your data. So let's have a look at this example. So have a look at it for a moment. So this is an example of a reification. So what does it say here is that, well, first we have a factual statement. So Bob likes chocolate. And then we have, we encode it as a statement. So we say that, okay, so this is a statement, and the subject is Bob, predicate. So the subject of S1 is Bob, the predicate of S1 is likes, and the object is Bob. So this is the M3 format here. And then you present another statement that Alice believes about this statement. Is it a knowledge? Is it an actionable knowledge? Maybe not. This is just well, a static factual description that Alice is in certain relation to this statement. So it's not actionable. So it's not a belief that you can, it's not a rule that you can apply in reasoning. So RDFs, so we need something more than just describing the data. So we need to describe variables. We need to describe formulas. We need to describe implications and such. And that is the actually the most important part of N3 notation. So so notation 3 was invented not only for kind of clean representation of RDF statements, but expressing more, so to make knowledge more actionable. So if we have a look now at this piece of code. So then what we see here, this is also in notation 3 formats, but now we have some curly brackets, so it means something different. And then we have even some nested structure with curly brackets. So how it is interpreted is pretty much like this. So in the curly brackets, we have a formula, so it's not an assertion. And here we have something. Again, that is a common to the reasoner that tells that well, some statement implies other statements. So basically, on this notation of the knowledge, you can create a program, you can write a code that performs reasoning. But again, the underlying description will be RDF. So as you will see later, this N3, well, the reasoners are not based on this particular way of representing knowledge, but rather on a more advanced language, which we will look at in a couple of classes from now. But this is just for your information that so N3 is much more than can offer much more than RDF. So it is used to abbreviate the RDF statements, but its original idea even to be able to express general rules, not just facts. Yes. I think I will stop now, not to mix the contexts. So next time we will talk about transition from RDF to more hierarchical representation of data and to a more powerful language for describing ontologies, which is OL. And I will also introduce a tool for managing ontologies, which is Protege, which we will use in lab 3. So that's it for today. So thanks. Any questions about this? Yeah.
So when you use N3, all things written in N3, can they be, can we display them in the RDF like visualizer? And will these curly brackets?
Let's try it out. Let's try it out. So let's see. Let's see. I think it is additional functionality, of course. So the control A. Oops. It didn't like it, no. No, it's much more. So it's meant to be for actually for the reasoners. So it's a kind of a language on top of RDF. So it embraces RDF as fact descriptors, but also allows to express rules and variables.
Yeah, so some things written in N3 will not be able to be shown as
not as graph, no. I mean, if you use this inference or reasoning related constructs, so it won't be written as graphs. Where you can see it, Later on, you can we will talk about rules. So when you have statements about facts and relations and such, and then on the side you can create rules that if certain facts included in certain in some relations, then do something. And these rules, they could be expressed in N3 formats. So there is such term as precondition matching. So you express your condition. So if your knowledge base meet these conditions, then do something. So that's kind of I mean, it's also a variant of reasoning. So the condition can be expressed in N3 format. Yes, but you need obviously a special interpreter of this. Yes. Okay. So good luck with lab 2. So lab 2 is still it's a continuation of lab 1, more or less. So you will use your parser of predicate logic for implementing the engine, the reasoning engine. So good luck with that. And in lab 3 will be about semantic web, so ontologies and reasoning and ontologies. And reasoner, so it will be quite interesting new task. Okay, good. Thank you.